Hi, we're Carolyn and Fiona, and today we're going to be reminding you guys about AP Precalc topic 2.9, which is logarithmic expressions.
Live from G25, let's go. Statistic, yep. Statistic, yep. Statistic, yep. Statistic, yep. Miss Law, Miss Law, Miss Law, Miss Law.
Thank you for that, Timothy. So, what is a logarithm? A logarithm is just another way to write an exponent in a way that answers the question, to what exponent do we have to raise a certain base in order for it to output a given number?
So using logarithms can help us simplify calculations and express relationships in a more manageable way, especially when we're dealing with particularly large numbers. They also provide a way for us to solve incomplete exponential functions by rewriting them as log functions. So some things to know: a common log function will have a base of 10, and if a base is not written, just assume it's a common log function. Another common base is e, which is approximately like 2.718, and that is called a natural log.
This is what a logarithmic function looks like on a standard graph. The general form of a log is log base b, a equals x, which is equivalent to b to the power of x equals a. For example, 2 to the power of 3 equals 8 is the same as log base 2, 8 equals 3. This is useful in solving the equation where the variable is in the exponent.
Okay, the three main properties of logarithms we're going to go over in this video are the product rule, the quotient rule, and the power rule. The first one, the product rule, states that log base b mn is the same or equal to log bm plus log bn. So for example, log base 3 9 times 27 would be equal to log base 3 9 plus log base 3 27.
The quotient rule is similar, except we switch multiplication with division and addition with subtraction. Log base b m over n equals log base b m minus log base b n. For example, log base 5, 25 over 5, is the same as log base 5, 25, minus log base 5, 5.
Okay, finally, the power rule states that log base b m to the power of n is equal to n times log bm. So an example of this would be log base 2 8 squared is equal to 2 times log base 2 8. These properties are what allow you to expand or condense equations to solve and simplify logarithms.
Two more key terms to know are common and natural logs. This simply means the bases, value b, are 10 and e, or approximately 2.718, respectively. If there is no base written, you should assume it's base 10.
So let's do some example problems. To review like the very basics, we have log base 2x equals 5. So we can just rewrite this into exponential form, and it would be x equals 2 to the power of 5, which is also equal to 32. So x equals 32. To practice expanding an equation, we are given log base 2 4x to the power of 3. So the first thing we should do is use the product rule to expand it and rewrite it as log base 2 4 plus log base 2 x to the power of 3. And then using the power rule, we can rewrite it again as log base 2 4 plus 3 times log base 2 x.
For a second example, this time condensing an equation, we have 2 log base 3 x plus log base 3 y. By using the power rule in reverse, we get log base 3 x to the power of 2 plus log base 3 y. Then the product rule in reverse gives us log base 3 x to the power of 2y.
An important note for when you're using these methods to solve for x is to always check for extraneous solutions. because logarithms are undefined for 0 or negative inputs because of their exponential properties. The a value in the original equation, if it is 0 or negative, if the solution is undefined. To graph logs, we can use a logarithmic scale if you want to, which looks like this. And increases by the powers of a number, usually by 10, instead of increasing linearly. And this can be used to represent very large or very small numbers on a graph and better show relative change. But you should make sure, let you know if the function graphs in a linear line on a logarithmic scale is going to be exponential, not linear, because of the scale factor of the graph. So it's a little bit misleading.
To review, logarithms are really just a different way of representing exponents, and you should be comfortable with using product, quotient, and power rules to simplify or expand logarithmic expressions. You should also know the definition of common and natural logs. Thanks for watching!